All right, so we're going to be talking about special right triangles. So we have two special right triangles that we're going to learn the properties of. So the 45-45-90 triangle and the 30-60-90. So first one, 45-45-90, is also often called the right isosceles triangle because it has two congruent angles here and two congruent sides. We're going to learn about the relationships between the sides, but it's also important to know these other things. And then we also have our 30-60-90 triangle, which again refers to the angle measurements of our triangle. And they have a 60-degree, a 30-degree, and a 90-degree. Again, we're going to learn about the side relationships for these triangles. And the reason these just come up a lot, there are a lot of times that a 45-45-90 triangle comes up or a 30-60-90 triangle comes up. And so learning these sort of shortcuts to solve for the sides is going to be useful. Okay, so let's go ahead and take a look at where the relationships come from a 45-45-90. So let's look at this triangle and let's say that the legs are equal to x. So we're going to say each leg here is equal to x. So this leg's equal to x, this leg's equal to x. And we want to figure out what the length of the hypotenuse is in terms of x, or in terms of the leg. So we're going to use the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. And we're going to solve for that hypotenuse in terms of the legs, in terms of x. So combining terms here, we get 2x squared equals c squared. And then to solve for c, we just need to take the square root. The square root of 2, that's actually irreducible, but the square root of x squared is just x. So we actually found that the hypotenuse is equal to the square root of 2 times x, or that's often written as x times the square root of 2. Now what this lets us do is if we know any one of these sides, we can figure out all of the others. If we know this side, we can just divide it by root 2, figure out the leg. If we know the leg, we can multiply it by root 2 and get the hypotenuse. Pretty nice, pretty simple relationship, and we're going to go ahead and do that. Here's the work shown out again in nice math type. All right, so again, in summary, the legs are x, the hypotenuse is leg times root 2, or x times root 2. All right, so in this problem, we know one of our legs is 17. So one of our two legs is 17. So the other leg is also 17. Those are our x sides. And the one we're missing is our hypotenuse, which is x root 2. So that means we just need to multiply our leg times root 2, and we can leave it like that. We could multiply this out and get a decimal approximation if we want to, but we're going to most of the time want to leave this in this exact format. But if we wanted to multiply it out, this is around 24.04 something, however we want to round it. But for our purposes, leaving it in this exact format is going to be preferable. So that was kind of an easy one. We're gonna keep working it up till they get harder and harder. All right, the next one, and this one we know the length of the hypotenuse. It's actually a funny length because this is not a reduced fraction, but that's okay. We know the length of the hypotenuse. The hypotenuse, remember, is x root 2. So we can kind of use this to figure out the lengths of the legs, which are x's. I like to sort of set up an equation here. I like to say, all right, fine. 3 root 2 is my hypotenuse, and that is equal to x times root 2. By solving this equation here for x, I will have solved for the length of the legs. So I just need to divide both sides by root 2. Divide this by root 2. I get 3 square root 4. I divide the radicals together. Square root of 8 divided by square root of 2 is the square root of 4. Okay, well, actually, the square root of 4 is a whole number. Square root of 4 is 2, so this becomes 3 times 2. So x is actually equal to 6. Our legs here are actually equal to 6. That also means that this length right here, 3 root 8, actually is not in a reduced form because we know that 4 is a factor of 8. So this is not a simplified radical. So I could simplify this down a little bit this way. Square root of 4 is 2, so this becomes 3 times 2 times root 2. So this is actually the same thing as 6 root 2. So instead of this, the proper form this should have been given to us in is 6 root 2 as with a reduced radical. And now we can see how this is x times root 2, and that these are x's. But it made it a little harder to have it kind of confused and mixed up in that other way. All right, and then here's the last one. This one's going to be kind of the hardest one. So in this case, we know the hypotenuse, but we know the hypotenuse and it doesn't have a radical in it at all. Whew, that's going to make it difficult. So we have x root 2. This is somehow equal. We need to figure out how. Okay, and then our two legs obviously are the x sides. These are equal legs. So we need to solve this equation. We could think about it in a couple ways. We can think, all right, well, what do I need to multiply by root 2 to get 16? You could think about it that way, but that's not too easy. I could also just simply divide both sides by root 2, and that's what I'm going to do. But that's going to bring in this new idea of rationalizing, because I don't like my answer to stay in this format. Anytime we have a radical in the denominator, that is not the preferred way that we want to have it, and we want to get that out. So we do this process that's called rationalizing. So I'm going to take 16 over the square root of 2, and I'm going to do that process to it. Again, this is called rationalizing. It comes from the fact that the square root 2 is an irrational number. It is a non-terminating, non-repeating decimal, 1.4142 something, keeps going on forever, just like pi. Pi is a non-terminating, non-repeating decimal, and we generally don't want those in the denominator. That's just a standard way of reporting our answers that we sort of all agreed on in math. So what we need to do is we need to multiply the bottom and the top of this fraction by the same thing, by this radical. So we multiply the top and the bottom by the square root of 2. The square root of 2 times the square root of 2, which we get on the bottom, is the square root of 4, which becomes a 2. Square root of 4 is 2. And then on the top, we don't really do anything here. We just kind of put these two things together. Square root of 2 times 16. And then notice how these will divide evenly. 16 is evenly divisible by 2. So this can actually reduce even further into 8 root 2. So that is actually what x should be equal to. X should be equal to 8 root 2. 8 root 2, 8 root 2. This rationalizing process is pretty advanced and something you're going to have to do next year in AP Prep Algebra 2. So getting used to it will be useful. But I'm also okay if you go ahead and leave your answer right here like this as 16 divided by the square root of 2. That's okay also. All right, and then we have the 30, 60, 90 triangle. So where does the 30, 60, 90 triangle come from? 30, 60, 90 triangle comes from So the 30, 60, 90 triangle comes from this. We're going to start by drawing an equilateral triangle where all of the sides are equal to 2x. 2x is just an arbitrary length. 2 is going to make it useful for some of the things that we do. So 2x. And then what we do is we draw an altitude, a line right down the middle that is perpendicular to the base. And that creates a 30, 60, 90 triangle. So what I'm going to do is put a square around that. So we've created this 30, 60, 90 triangle right here. We have this side, which is the hypotenuse of the 30, 60, 90 triangle, is the same side as our equilateral triangle, so it's 2x. And then we have this leg right down here, which is x, because it is half of the side of this equilateral triangle, which used to be x, so half of that being, which was 2x, so half of that being x. The part that we're missing is this leg right here. We're missing b. So we're going to solve for that in terms of x, so that we have all three sides of our 30, 60, 90 written in terms of x. And so that's what we're doing right here. We set up this Pythagorean theorem. leg squared plus leg squared equals hypotenuse squared. And we go ahead and solve that, and we end up finding out that that the leg here is equal to exactly the square root of 3 times x. That's nice, square root of 3 times x. That is a value that we can use to help us figure things out. So let's take a look at actually using this. So here's our 30, 60, 90 triangle. The short leg is x, the long leg is x times root 3, or the short leg times root 3, and the hypotenuse is 2x, or 2 times the short leg. So everything is written in terms of the length of the shortest leg here. Let's use that. All right, so now 30, 60, 90 triangle. We want to identify our different angles. This is a 60 and 90, so this one over here is a 30. 30. We know currently the hypotenuse, right? The hypotenuse is our 2x side. We are missing the short leg and we're missing the long leg. So we know the 2x side. So we can solve for x for this triangle pretty easily. 2x equals 10, divide both sides by 2. And remember, x is just the length of the short leg. So this one's 5. And then our long leg is just equal to the short leg x times root 3. So 5 square root 3. Not too difficult. This was kind of an easy example again. It's all about figuring out which side we know, which in this case was the hypotenuse, using that to solve for x, or the short leg length, and then using that to figure out the long leg length. Pretty easy example right there. Next one, well, going to be a little bit harder. All right, so on this one, we are given the short leg. This is our short leg. It's the short leg. It's across from 30-degree angle. It's the shortest side. That's our x. So the hypotenuse is the 2x, and the long leg is the x root 3. Well, if we know the x, then we can just use that to find these other ones pretty directly. The only thing that makes this difficult is working with this radical. But 2 times x, or 2 times 2 root 15, is just going to end up being 4 root 15. So this side is 4 root 15. The hypotenuse is 4 root 15. And then this side, the long leg, is equal to x, 2 root 15 times the square root of 3. Again, working with radicals is what makes this a little more challenging. We multiply our radicals together. 2 root 45. But root 45 simplifies. 2 times the square root of 9 times the square root of 5. Square root of 9 is our biggest perfect square factor of 45. And the square root of 9 is 3, so this becomes 2 times 3 times root 5, which is 6 times root 5. So our long leg is 6 root 5. Again, a little bit difficult, but what's making this difficult is learning this operation with radicals. All right, let's go ahead and clear this and move on to our last example. All right, here we go. So in this one, we know the long leg. This is the x root 3 side. So this one's going to be difficult. Generally, when we know the radical side, that makes it a little harder, but sometimes not. So we're going to have to solve an equation. X times the square root of 3 equals 9. Divide both sides by the square root of 3. And we get x equals 9 over square root 3. Again, this is not the preferred form of our answer, but for right now, I would accept it. Really, we should rationalize this. So I'm going to go ahead and do that. I multiply the bottom and the top by that radical. Square root of 3 times square root of 3 becomes the square root of 9, which is 3. So we end up with 3 on the bottom. And then on the top, we can't really do anything with that. Just put those together. 9 is evenly divisible by 3, so we actually end up getting that x is equal to 3 square root 3. That's great. That's our short side. And this side is 2 times that, which is 6 root 3, right? 2 times 3 is 6, so we get 6 root 3. Again, this part is the part that really makes it hard is this part here in red, this rationalizing. And again, this is just sort of an agreed upon form for these types of expressions, just so we all end up with the same answers. and they look nicer, they look cleaner. This looks a little better as a final answer than this. All right, and that's it. Good luck. Make sure to do the homework problems on chapter 5.8 and turn in those homework assignments in your Google Classroom. And I'll see everybody later.